today. This is lesson 7, distance on the coordinate plane. And we're getting close to the end of this chapter. And you know what? Don't be too tricked by anything in this lesson, because this is basically another way to look at the Pythagorean theorem, another way to use the Pythagorean theorem. So let's take a look at this, because there shouldn't be anything too shocking in here, I wouldn't think, except if my computer will not let me move. All right. Hey, guy, hey, look, they're looking at a map. That's so cool. All right. Now, we'll come back to this. Don't freak out about this. It's not a big deal. It's just the Pythagorean theorem, really. That's all it is. So let's go up here if it'll let me. Okay. Come on. So it's showing you how you can use the Pythagorean theorem to figure out the distance between any 2 points that are on a graph. Because you have a point here and a point here. And if you see what they did, they say, well, what's the distance between those 2 points? Well, the distance between those 2 points would be just doing the Pythagorean theorem, because you have 5 going down. So from here to there is 5. From here to there is 4. So it's all about the distances. And then you have the Pythagorean, a right triangle. And at this point, all you have to do is figure out what the, let's use green this time, what the third side is, what C is, because I know it's going to be 25 and 16. That's where they got the 41. And that is C squared right there. And you just have to take the square root to get the distance between the 2 points. All right, that's how to do it. If you're given a graph, you can just see, again, you can see how much is it down, how much is it over, and then you've got your triangle, and you can do the Pythagorean theorem. Now, the formula they give you does work, and if you get the formula in your head pretty well, then it just saves you a step. So now here's the formula, this distance formula. And if you look at it and you're like, well, this is weird, I've never seen anything like this before, with the x and y, and then the square root. Well, if you think about what we just talked about, it's like you take your x's and you subtract the x's from each other and you square them. Well, that's what we did up here, up above too, was we just said, how far is it from here to here? That's x. What's the distance? And that's where you get, you have this x2, which, if I get my pen on again, x2 goes from right here and x1's over here. So that's where you're subtracting, just to say how far is it from here to there. And then for the y's, you're saying how far is it from here to there. And so that's your triangle. So what the formula does is subtract your x's, subtract your y's, square them, add them together, take the square root. That's the whole thing. That's the same thing, because if you say you have a number here, if this is 3 and this is 4, you're doing the same thing. You're saying that the difference between here and here is 3, even though it looks like a weird looking 8. And distance from here to here is 4. The y up here minus this y is 4. So then you have your 16 and your 9. So that's what we're doing. We're saying the distance, the differences between the two. How far apart are they? How far apart are the x's? How far apart are the y's? Then, like we've done every other time with the Pythagorean theorem, we add them together. And in my example here, you're going to get 25. And then you take the square root, and that tells you that this right here is 5. That's all there is to it. So it's just a nice formula to use to look back on, so that you can maybe have a little bit of an easier time getting there, instead of having to draw the picture and do the graph. Over here on page 433, it shows this method 1 and method 2. That once you're using the Pythagorean theorem, once you're using the distance formula, there's really not a difference this is the one where you're thinking of it as a triangle, and you maybe are going to draw the sides to figure out that third thing. And the other one is using the formula, which is the same thing. You still have your point, and they're using this. My triangle didn't work out well, but we'll say this: they're using the negative 1.5, negative 1.5, and then they're doing 1.5. Whoops, that's a 1.5, 2. And so, they're doing it the same way, and they're saying, okay, so if I look at my x's, negative 1.5 to 1.5, I think that's a distance of 3 from here to here. And then, actually, with the way I've written it, it should go up. But if you're going from negative 1.5 to 2, that is a distance of 3.5 from here to there. So yeah, I know you'd have to draw it and label it the right way, but and so they're just doing it. It's really the same thing. They're doing it two different ways, sort of, but not really. It's really the same thing. So there are not the two methods. It's just, how are you going to do it? If you're going to get the same answer. If you like to use it with a triangle, that's fine. This is the other, with the distance formula, and you can do it that way too. There you go. Let's see down here. Let's go to the next page and see if it lets me go there. Not yet. There we go. And here's another look. Part 2. I think part 2 of the second video. Is it part 4 then? I don't know. So in this one, I believe my one mark was here at 4.5 and 2.2. And so then, you can say, oh, let's see, I think that side looks like this and that side looks like this. And so it looks like a 3 and this one looks like a 2. Right? So you got to figure out this length right here. So 9 plus 4 is 13. And so I believe that we're looking at the square root of 13. And whatever that is, that's your answer for that. So you can do, you can do it that way. If you want to use if you want to use the distance formula the whole time, that's fine too. Because like number 4 here, they give you a couple ordered pairs. And now this is an interesting one because they say that each unit on the grid is half a mile. So they're talking about how far it's going to go. You got to be careful at half a mile, because when you figure out the distance here for that, and you could graph it, or I would just put the numbers in. When you put in the numbers for the distance formula, you just need to make sure, I guess it doesn't matter if you're squaring everything. So, how far apart are the x's? To me, looks like they're 2 apart. And how far apart are your y's? It looks like they're 10 apart. So that's 10. And so then, I'm going to get a 4 and 100. So it's 104. And you have to do the square root of that. But then you need to remember that each unit is half a mile. So to figure out miles, you would have to divide everything in half. Because, one mark is going to be half a mile. So divide it in half. There you go. So that's that. And that's what a lot of the things are going to be like. Are you going to do it with the graph? Like this one you can do with the graph. Others maybe not. So see what you can do. See if you have any trouble with any of those. And then this is a good one. I can check these over with you when I get back on Thursday. And straightforward stuff. Just look back, ask each other questions, see what you can figure out, see if you have any trouble. I don't remember if there's anything too weird here. Nope, nothing too weird. So there you go. That's about it.